Hi everyone. So today I'm going to talk about scalars and vectors. Okay. So scalars are quantities, are measurable stuff that are only described by their magnitude. Magnitude means their size or their amount. And let's talk about some examples of scalars. For example, how much you weigh, how tall you are, what is the distance from A to B, and things like that. See, if I say I'm 130 pounds, it really doesn't matter if I'm sitting on a chair, if I'm walking to school, or anything like that. As long as I'm 130 pounds, you get to know, for example, what is the size of my body, or and whatnot. However, there are some quantities, we are call them vectors. So these vectors are described both with their magnitude and direction. And please be careful, direction is indeed as important as the magnitude of a vector. Some vector quantities are like pushing force of a car. For example, if there is a car here and if you want to push it towards some direction, it's important the direction towards which you push the car. For example, if you push it this way, it goes this way. If you push it the other way, it goes the other way. These are vectors, and basically their magnitude, their size, and their amount is as important as the direction towards which they are acting on an object. We already know how to add and subtract scalar quantities. For example, if you have 2 apples and you add another 2 apples to it, you end up with 4 apples. Or if you have 5 apples, you eat 3 of them, you end up with 2 apples in the end. That's pretty much something, you already know by default. It's a common sense to you. As for vectors, vector addition. So in order for us to add vectors, we need to be a little more careful. What it means is that, for example, if there is a car here and we are pushing it with 2 different forces, let's say there are like 2 people here pushing the car towards this direction, by default, we know the forces add up to a bigger number. However, we know if a car was like sitting right there and there was one person pushing it this way and the other person pushing it the opposite direction, depending on the fact that which of these forces are bigger, the car would move that way. For example, if this was 3 and this was 5, by default, common sense wise, we know that the car eventually goes by 2. By amount of force equals 2, so regardless of what the unit for force is, by 2 this way towards the left. So as you can already see, the direction of some quantities that we are called vector actually matters, towards left, towards right, etc., etc. Now, vector addition is this way. So, first and foremost, we denote a vector by its size. So, the size of the vector tells you how big the vector is. For example, this vector is bigger than this. This vector is also bigger than this. And also, like I said, that was the magnitude of the vector. Now, in terms of the direction of the arrow essentially tells you towards which direction the force, towards which direction the vector is directed to. Now, if I have 2 vectors, let's say one is let's say I have vector A towards this direction, and I have another vector called B towards this direction. If I want to add these two up, this is what I need to be doing. There are two ways for vector addition. One of the ways that we can add two vectors is putting both, basically gluing two tails together, and as long as the vector I'm drawing here is the same size and in the same direction as B, we are basically dealing with the same B. So all vectors with the same size and same direction are equivalent. This is very powerful. We use this a lot, and as you just saw here, this is one of the instance that we actually use this property of vectors. Whenever you're working with a vector, if you draw exact same vector with the same direction, you are essentially dealing with the same vector. So here we're dealing with A and B, and we're gluing the tails of both vectors. If you ever do this, this is how you get the addition of them. So let me just erase this. And this is how you do it. You draw a parallel line to one of them with the same size. You stop there. Then you draw another line parallel to the other one, and you stop there. The point where they meet, it is going to be the tip of the resultant vector, and the tail of the resultant vector is basically where the other two tails are glued. Okay? So A plus B gives you C. Okay? There is one other way we can do this. This is how we do it. You have your A. You go, so you have tail, tip, tail of B, tip of B, and then the resultant vector is having its tail at the tail of the first vector and its tip at the tip of the last vector. Please remember, please note that you can be having a lot of vectors this way. However, the resultant vector is the tail of the first and the tip of the last. This is the resultant. This is the resultant for this one. Just make sure you understand. And as you can see the resultant vectors are parallel and with the same size. So you just saw that we got the same result both ways. Whichever way you are more comfortable with, go for it. As long as you do it correctly, you are good to go. Okay? Next, I'll talk about velocity, speed, displacement, and distance. Bye now.